Degree is always what is the highest exponent. It's not always going to be the first thing. It's what's the highest, okay? So, for example, in this one, question 6, what's the degree of this one?
4.
Good. Yeah. A little trickier, right? Okay, cool. What's the leading coefficient then?
Is it x or just like 1 because it's the first one?
It's just 1. So it's whatever the number would be in front of the x to the whatever with the highest degree, whatever the number is. So in this case, because there's nothing in front of it, it's a 1. It's not a 0. Some people say it's 0. No,
All right.
Okay. So what about for this one? What's the leading coefficient?
8.
Ah, tricky. Remember, leading coefficient is the number in front of the highest exponent.
In front of.
Which one was the highest
7.
exponent?
Okay,
so it's
7.
7. Yes, this is the highest exponent, so it's
okay.
7. Yeah. I know, leading makes it feel like it should be like the first one, but no, it's the one in front of the biggest one. Okay.
Yeah, I got it.
End behavior. Okay, I guess they probably mean like to the left and to the right, like which way it goes, right?
Yeah, that's what like throws me off. That's like the only thing I don't know.
Okay, so here's the thing. So if the degree is even, then the end behavior is the same for left and right.
Okay.
But if it's odd, then it's a different end behavior, okay? End behavior is just saying like what happens as we go to positive infinity and what happens as we go to negative infinity for x, okay? So
Okay.
a good one here, let's say, for instance, I just have like f of x is equal to x squared, okay? Do you know what this graph looks like?
Yeah.
What does it look like? Like, describe it as like a letter.
A T.
A T looks like a U. Looks like a U. Looks like this.
Wait, what are you talking about? Oh, I thought you were talking about like the actual thing. Okay.
No. It looks like this is what x squared looks like. It looks like a U.
Oh, okay.
Right?
Okay.
Okay.
Yeah.
Notice how what is the degree? The degree is what?
2.
2. Good. Is that degree even or odd?
Even.
Even. Okay. So that means the behavior to the left and the behavior to the right will be the same. Okay. So then what you do is you just look at whether this thing is positive or negative. Okay. So because this is positive, that means the behavior to the right is positive infinity, and the behavior to the left is also positive infinity. Okay.
Okay.
Because if the degree is even, it means the behavior is the same for both. And in this case, if it's positive, they're both positive. What if it was, for instance, negative like 3x squared? What would the end behavior be on the left and the right?
Would it be what do you mean, like in terms of the
like
letter would be like you?
Like positive infinity or negative infinity. End behavior is just saying like what y value does this tend to go to? That's what they're asking. Okay.
Would it just be negative infinity?
Good. It's negative infinity. And more importantly, because it's even, it's negative infinity for both. Okay? So,
yeah.
Again, I don't know exactly how your teacher... Do you know how your teacher wants you to write this?
No, because she gave it to us today.
Oh, okay.
And she didn't really give us like a reference at all.
So I would say like, as x approaches negative infinity, you say y equals negative infinity. And then you say as x approaches positive infinity, you're going to say something else. Yeah. Okay. This is... Have you seen this writing before? This is called like limit definition.
I have not seen that yet.
Okay, cool. Yeah. Okay, so, that's for things that are even. Things that are odd are going to be a little bit different, okay? So, let's say, for instance, we have y is equal to x cubed. Okay? X cubed, you may not know, looks like this. Okay? What is this behavior as we go to the right?
Positive infinity.
Good. And what about as it goes to the left?
Negative infinity.
Yeah, good. This is positive. This is negative infinity. Okay, so cool. So look at this. Because it's odd, right? Do you see how the right behavior is opposite of the left behavior?
Yeah.
Okay. And then for odd functions, if this is positive, left is going to go down to negative, and then right is going to go up to positive infinity. Okay? If this switches, okay? So if we do, for instance, y is equal to negative x cubed, then it's going to look something like this. So now it flips. So now as you go to the left, this is positive infinity, and then as you go to the right, what is it going to be?
Negative? Oh no, wait, it's still positive, right?
No, it's negative. It's negative. You were right
Oh,
the
it's
first
negative?
time.
Okay.
Right, because remember, if this is odd, right, 3 is odd, then the behavior on the left and the right has to switch. They have to be opposites. So it has to be positive infinity here and negative infinity here. Yeah. So good little little thing for it. Okay. All right.
Yeah.
So let's look here. And again, you always look at the leading coefficient and the degree. This is what determines this. Okay. So let's remember. Okay, the leading one, right, is this x cubed. What does that mean about the end behavior on the left and on the right?
Can you repeat that? You cut out.
It's okay. What's the end behavior for this one?
For that one?
Yeah.
Would it be like? How would I say it? Like,
Yeah.
because since the leading coefficient is 3.
Yeah.
The degree is 3.
The degree is 3, right? So I would write like what it is, right? It's odd. Okay. It's an odd. I would write whether it's an odd or even function. That's just a good thing to write. Okay. And then I think you can do it kind of like this. Just do like left behavior, right behavior.
Okay. So like in a what's the thing called? I forgot.
Parentheses and a comma or something. Brackets. I don't even call it.
Well, damn, it's gonna bother me, but I know. I know what you mean.
Like a range, like a domain or something.
Yeah, something like that. I don't know.
Yeah. Okay. So what's the left behavior and the right behavior for this function?
Would the left one be 3?
No. So
or
remember,
0?
so your behavior is either positive or negative infinity. Those are the choices you get. So it's either positive infinity.
Oh, it's negative.
Or negative. Good. It's negative, right? And then because it's odd, what does that mean about the right behavior?
Positive.
Right. And good. It's positive. Good. Yeah. Positive infinity. Okay. What about this one?
That one.
So first of all, what type of function is it? Is it odd or even?
It's odd.
What's the degree?
Does it go by the degree or the
goes by the degree
coefficient?
Yeah. Don't worry.
Right.
This is they're trying to fuck you up here by putting this one first.
Yeah, it's throwing me off. Yeah.
This is bad form. Usually you would put this one first, but they're doing this to mess with you. Always look at the degree.
So it's gonna be 7. So it's gonna be odd.
No. You look at the degree.
Oh, the degree. Yeah,
the degree.
Yeah. So yeah, okay, even. Yeah, okay.
Even
this
function.
Is throwing me off.
I know it's a tongue twister. Okay. All right. Even function. So what's the behavior on the left?
Hold on.
Let's remember for even functions, right? If you ever need to remember, just remember what like an example even function is, right? This is x squared. This is an even function, x squared.
Okay.
What's the behavior on the left?
Positive.
Yeah, it's positive infinity. Okay. And then because it's even, what does that mean about the right behavior?
Is it also going to be positive?
Yes, good. Nice. So yeah. So again, look at the degree, odd or even. Okay. And then what you have to do is you have to look at the leading coefficient technically, because if this coefficient were negative, for example, these would flip. Okay. Then the left would be positive infinity, the right would be negative infinity. If this leading coefficient, let's say, was -7, then these would both be negative infinity.